Universe. Evolution of stars whose mass is 5 times or more than the solar mass. The birth and the life of a star is a fascinating journey. The evolution of stars which have mass 5 or more times than the solar mass has several stages of nuclear reactions after the formation of the red giant. Formation of a protostar. When huge gaseous clouds of hydrogen contract due to gravity, there is an increase in density leading to increase in pressure. The cloud finally has a spherical mass made of hydrogen at its core, called the protostar. A protostar has a hydrogen core and constitutes about 99% of the cloud's mass. Formation of a steady star. A steady star is formed from a protostar due to nuclear fusion of hydrogen to form helium. The energy released tries to expand matter in the star. Eventually, the outward pull due to the radiation generated during the expansion balances the inward gravitational pull. The protostar reaches a steady state and is called a steady star. The process of fusion continues, and this forms a helium inner core. The inner core is surrounded by hydrogen which continues to fuse at a rapid rate to form helium. When the hydrogen is used up, it expands to form a blue supergiant. The energy released causes the star's outer envelope to expand and therefore cool. The color of the star changes to red, and the star is called a red supergiant. The star's envelope expands while its core contracts, resulting in a very high temperature of about 10 to the power of 8 Kelvin. Resulting in the fusion of helium to form carbon. Once the fusion is complete, the core cannot contract further. The outer envelope of the red giant gets detached and is thrown into the outer space. It forms a cloud of hydrogen gas called a planetary nebula. The carbon core produced ignites further to produce a core of oxygen. When a new core is formed, it is placed inside the existing core. The chain continues, leading to the production of heavier elements. Silicon, like magnesium, iron, etc. The supernova. When iron forms the innermost core, the star explodes, and the event is called the supernova. During supernova, most of the materials are thrown out at speeds of 10 to the power of 4 kilometers per second. The supernova initially looks like a nebula. A sphere of neutrons called neutron star remains at the center. They gradually mix with other gaseous clouds to initiate star formation. The stars formed this way will be made of elements heavier than hydrogen and helium. When the neutron star spins rapidly, it acts like a pulsar, sending out pulses of radio waves. A black hole. When supernova occurs for stars whose masses are about 30 times the mass of the Sun, a huge amount of matter is compressed into a small region. This region has intense gravitational field and is called a black hole. Features of a black hole. 1. Any object can become a black hole if it can be compressed to a sphere of radius less than a certain minimum. Example, the Sun would become a black hole if it is compressed to a radius of 3 kilometers. 2. The only recognizable property of a black hole is its mass. 3. Properties like temperature, pressure, chemical composition of a black hole cannot be determined. This is because any information signal sent in the form of light or radio waves into the black hole is absorbed by it. The presence of a black hole can be felt by studying the gravitational force it exerts on bodies close to it. In star evolution, the end state of a star depends on the mass of the star. The star can have 3 end states, namely the white dwarf, the neutron star, and the black hole.